Welcome to EDU World Space.
We're told that we have this section here swept around the x-axis to form a solid. So what we have is basically a truncated cone that has a base radius of 2h and a top radius of h. And we want to find the mass moment about the x-axis here. Well, it's simplest to use polar coordinates, and we know then that the radius at any given cross-section of this cone is h plus hx over a. So as we go from x equals 0 to x equals a, we go from a diameter or width of 8 or a radius of h to a radius of 2h. The area of the mass moment about this axis here is the density times y squared plus z squared, which would be an axis out of the page here. And that's just the same as r squared. Okay, so in polar coordinates. So we need to integrate rho r squared over the entire volume. And the volume we can break into, again, using polar coordinates. So we get r dr, so this becomes an r cubed. Then dx d theta. R goes from 0 to r1, this function here. X goes from 0 to a. And theta goes from 0 to 2 pi. And we can crank through this integral. It's just a little tedious. And we get 31 over 10 pi rho a h cubed. We can also calculate the, and I think I have, this should be a squared. We can also calculate the volume by just putting 1 into here. And we can crank through the calculus and get 7/3 pi ah cubed. So the density is the mass divided by the volume, since it's uniform, as we were told. And so we can substitute this into here, and we get that the mass moment about this axis is 93 over 70 mh squared, or 1.329 mh squared. So about this axis. So if we were trying to spin it, that would be the inertia that we'd have to the inertia, the j times theta double dot, when we have to spin this up to get put a torque on there.